Okay, good morning everyone. Today we're gonna start chapter 8, which is our last chapter in this class, and we're gonna start talking about arrays and strings. The concept of arrays is not new, but when we're talking about the string, we're gonna learn something new about strings in this chapter. Okay, so this is I think it's about the third time that we revisit what a string is as one of those data types that has a lot of its capabilities hidden in its structure, and it's an object-oriented design. So what we're going to be looking at is we're going to be looking at the reasons for arrays and how do we declare these arrays? What is a different way? How do we tell the system that it is not just a single identifier, what we are referring to in this case, but we're going to be referring to many identifiers of the same type, but we're only going to have a single pointer to it. So then we need to learn about how to manipulate this data that we put into arrays. And because we have many identifiers referred to by one single pointer, one single reference, that means we know where it starts, but how do we know where it ends? How do we know when to stop processing the array? And this is when we need to talk about definitions for array index out of bounds definitions. So we need to look at how do we declare and initialize arrays. Remember, when you declare a variable, the variable will hold garbage values. Now in this case, it's a lot of variables that we declare at the same time, so we're going to have a lot of garbage values. So we need to learn how do we initialize them. And we also need to look at what are the benefits and what are the restrictions with these arrays. We need to discover how to handle these arrays when it comes to functions. Okay, so we need to understand, just like we understood by talking about functions as they relate to enumeration types, we also need to look at how do we pass arrays to functions, and can we receive an array from a function. So we need to search how to we need to learn basically how to search an array, because we have all these connected identifiers. What if we need something in the middle of it? So we need to be able to search these collections of identifiers called arrays. And you'll learn that some of the searching algorithms are a lot better performing if we sort an array first. That's going to be very important for future classes, higher level classes. In higher level classes, you're not really just talking about the syntax of a particular language. In higher level classes, you kind of taking the language, the specific language out of the discussions, and you're really looking at data structures, which is really how do we solve problems and how do we solve problems faster. So searching and sorting is a very key concept in higher level understanding of computer programming. Now, some things that the compiler can do for us, like auto declarations. So we need to see how that works. And because we do have problems with how do we stop when we process an array, we need to really understand how do we use arrays in loops, so we don't make that ±1 type of a mistake like we talked about before in many different structures, we do make ±1 mistakes. So when we talk about strings, last time we talked about methods that we can use on strings to search and maybe manipulate the strings. Here what we're talking about is a different concept called a C-string, because now we know what array is going to be. So then we need to look at functions that are specific to C strings. Well, first we need to define them, right? So then we need to look at some of the functions, and then we need to look at how do we put data into, and how do we read data from these strange structures called C strings. Then we need to look at different ways of processing arrays, because we know that each array is going to have a specific data type associated with it. So what if we have many different data types? Can we process arrays with different data types? Well, we can if we look at arrays as, let's see, okay. So the basic concept about parallel array is going to be just like with your final project, right? What do you have in your final project? So in your final project you have numbers, okay, and let's say that's the customer ID. So the customer ID, let's not look at it as number, but let's see, it is a string. So maybe you read the customer ID as string, because we don't manipulate the ID, so we know it's a number, but really we can read it, let's say, as a string. And then we have number of channels. And let's say we have the regular and extra channels that we subscribe to. Okay. So anyway, so we have a string, we have number. Now how do we process this? Okay. Now what we can do is put each one of these numbers and strings into an array, and when we have this array, each one of the array can have an index, let's say 0, 1, 2. Okay. So if this is the string, let's say 0, 0, 1, 5, 4, 1, 1, then as we are referring to index 0, okay, even though these are separate arrays, index 0 will refer to the same customer, right? So we have the customer ID number, the channels, and the extra channels that the customer subscribed to. So item 0 becomes what later on, if you take database classes, right, you know that the horizontal line is going to refer to a record. So now you're talking about a record for index 0 that refers to the first customer. And then when you're talking about index 1, you refer to the second customer. So parallel array is basically taking the array with different data type, but each array item refers to a specific, that in that case, let's say a customer, right? So index, the corresponding index value throughout all the arrays that relate to each other store specific information about one specific item or one specific customer. So it's going to be a different way of looking at data. So how do we manipulate data in a two-dimensional array? Right. So So when we have 2 dimensions, that means we have to process something. Okay. So if we have 2 dimensions and we have more like a table, right? But why is it 2-dimensional array? Not like in my previous example that I said this is going to be a parallel array. When 2-dimensional array, each array element is still going to be the same type. But we have index values in 2 dimensions. Okay? So if you have something 5, then we need to look at which row and which column that 5 is residing in order to find that specific value. So that means we have to have something. First of all, we probably have to select a row, and within that row we iterate through each one of the columns. Okay? So what does that mean to us? So when we're talking about what does it mean to us in computer science, we're really looking at the pseudocode or flowchart. When you're talking about, let's say I select the row, right? Think about it like a clock, right? So you have the minute hand or the second hand, then we have the hour hand. Oops. First, we're going to have the minute hand, right? And then we have the hour hand. Okay. So what moves faster? The fastest moving item is the second, right? And after the second, what moves slower? Okay, so we do something with a second, counting the seconds. So that second gonna go from 0 through 59, but it goes really fast. So what happens when we exit out of that loop? Well, that's going to be our feedback into another loop that counts the minutes. Right? Because this loop moves a little bit slower. And then when that fails, that feeds back into another loop. That counts the hours, because the hour is the one that moves the slowest. Okay? And when that fails, we're done. So basically, when you're thinking about processing multidimensional arrays, always think about the clock. Okay? Always think about what is moving the fastest. Okay? Whatever moves the fastest, that's going to be the inner process. And if something moves a little bit slower, that's going to encapsulate what the fast-moving process is. So minute is a little bit faster moving, but not as fast as the hour. Okay, so the hour going to encapsulate the minute and the second. So as we are going, and let's say we have we start at 0 hour, right? 0 minute, 0 second. So the second is going to start running, and then we end up at 59, right? So that means we iterated through this loop 60 times. At that point, what happens? Our second goes back to 0. Minute increases to 1, but we do not change the hours. So what happens then? The minute starts a new iteration. Oops. It's right here, right? the minute starts a new iteration, and then the seconds start again. So what happened when a minute goes all the way to 59 and the seconds go to 59? So seconds were going really fast, minutes were going slower, and now when we go one more second, the second go back to 0. That takes the minute back to 0 and increases the hour to 1. Right? So the hour, the outer loop, you're going to see there's going to be a nested loop structure. The outer loop will be the slowest moving loop. So when you're talking about multidimensional arrays or two-dimensional array, again, you need to look at what is moving the slowest. So first of all, I need to take a row, right? So I have a table. Within a table, I have a lot of rows, right? So we need to go through the rows. And then when we're done processing, okay, so we pick a row, we start processing it. When we're done, what is it that we need to do? We go to the next row, all right? So we started at 0, now we're at 1. But that was much slower than going through each one of the columns, right? So we picked 0, and then we say 0, 1, 2, 3, 4, 5, 6. And then we go back to 1, and we say 0, 1, 2, 3, 4, 5, 6. Okay? So the row changes the slowest. And what happens? In each iteration of the row, we go through and process each one of the columns, right? And when the column exits, it goes to the next row. Okay? And when the row exits, we're done processing the array. Okay? So while it is true, the column going to increment, and while the rows are true, the rows gonna increment. Again, you can see this nested relationship between the rows and the columns. Anyway, so let's get started. Okay, so there's a lot of information in here that will help you understand how computers work. And so the simple data type, variables of these types can store only one value at a time. When we have structured data types, a data in which each data item is a collection of other data items. Okay. So when you're talking about an array is a collection of a fixed number of components, all of the same data type. So the data type is the one single type of a data. One-dimensional array components are arranged in a list form. And the syntax for declaring the one-dimensional array is your data type. Let's say it's an integer. And then the name is just an identifier, so we still follow a camel casing, right? So let's say I call it a list. And we can call it anything, long as it's not a keyword. And we try to be consistent with our naming standard, right? And then we say how many of those items we need. Okay, so in this case, it's going to be 5 items, and each one of them going to be an integer. Now the subscript operator, right? So we have this subscript, which is the index. So in that case, what it would look like, we're going to have set of memory, and within the memory, we're going to have 5 items. Now each one of these items is going to be 4 bytes. Now how do I know it's going to be 4 bytes? Well, 4 bytes because we know it is going to be an integer data type. So the integer data type consists of 4 bytes. Each one of them is 4 bytes. Now how do we find this? Well, the way that we find it is by pointing a reference to the beginning of this array. So who's going to be pointing there? It's going to be the identifier that we call a list. So a list is pointing to a list of integers. And how do we separate, how do we know which integer we're going to be referring to? It is by its subscript or index value. And that is the basics to understand. When we're referring to a particular value, let's say we want to assign 15 to the index location 2, we have to do that by the subscript operator. So we need to say a list subscript 2. Now notice this is the 3rd element, but index value is how we're referring to it, not the actual physical placement value. And at that point we use the assignment operator just like if this would be a single or individual integer variable. Okay? But now we refer to that integer with its subscript within this collection. So the int expression, any constant expression that evaluates to a positive integer. Okay? But it has to be constant, something that cannot change, because the way that we identify these arrays, or the way that we use these arrays in this chapter, is really these are static arrays. So we need to know the size of the array before we actually use the array in our code. So how do we access array components? General syntax is the name of the array, and then you have the index expression, which is some people just call it, or I like to call it, just an index. Now the index value cannot be negative, so the index value has to be basically an unsigned integer. Right? So if we say unsigned integer, we ensure that it's never going to be negative. So the value of the index is the position of the item in the array, and we use the array subscripting operator in order to identify which index value that we are referring to. And the index always going to start at 0. So this is the pretty much the same explanation that I kind of summarized at the earlier. Okay, so you have an integer of 10 items. Now those 10 items, look at the 10 items. The number 10 refers to how many items you have. But the largest index value, because we start from 0, the largest index value is 1 less than the actual item value, the way that basically humans are referring to items. I have 10 items, but really because we start counting at 0 in computer science, we're really looking at the ninth index value element is the last element in my 10 element list. So when we try to refer to the sixth element, we're really referring to, in computer science, to the fifth index value. And that sixth element, which is the fifth index value, equals to 34. So at that point, we assign the value 34 to the sixth item that is sitting at index value 5 in our integer array. So you might have to say it a couple of times out loud in order to really start making sense and not get too confused about it. Okay? So now we can do any kind of arithmetic, just like if you would do with regular simple identifiers, right? So here we could have said just x equals 10, right? And y equals 35. And we could have said z is equals x plus y, right? But why we don't use that? Well, why would you use that? If you just say discrete integer values, right? So if you look at the memory, in memory, these might be, x might be here, y might be here, z might be somewhere else, right? We have no clue how far apart these are from each other, or where they are in memory. The nice thing here is, because you are referring to index item 3 and 6, and the result going to be stored in 5, okay, you can actually have a simple arithmetic to actually calculate where these physical locations are, and how do we store the result of that in our physical memory. So it's going to be more structured. It's a little bit more organized way of looking at variables. And beside that, we do not have to come up with 3 different names, 3 different identifier names for our variables. We still refer to every single one of them as list, list, list. But the index value will tell us exactly which item in the list we need. And in that way, it can be kind of thought about it as X, Y, and Z. Okay? So can we do this? Is there any way that we could actually refer to these X, Y, and Z? Well, the easiest way would be, or the nicest way would be, right? If we would have, let's say, an enumeration type, and maybe I would call them, maybe we have variables, okay? And you might say that x is equal to 10, y equals 35, right? And then let's say you would say I'm somewhere here, z. Okay. No, I'm kind of lying right now. Okay. So really, what we need to do is let's try this again. Okay. So in the enumeration type, maybe if we say variables, not equals, but we start the list of items, right? So x is going to be 3, right? So it's going to be x is 3, and then we have, we need to have an ordered list. And in this example, z is 5. Okay. And then we have y going to be 6. So now we can replace this 3, 6, and 5 with the actual named component that maybe it would be easier for humans to remember, right? So this is why we learned enumeration first, and now we can use it in our array examples. So basic operations on a one-dimensional array is initializing and then inputting data. Then after we input the data, we need to look at how to output data from the array. And because we have a list of values that we store in the array, we might have to search that array and do some manipulation on that array before we process it. So each operation requires the ability to step through elements of the array. So whatever we do, if we're initializing it, or we're inputting data, or outputting data, or finding small or large elements in the data or in the array, we have to step through each one of the elements, because we cannot have aggregated operations. So in order to step through all the elements, we need to be in a loop. So that means, first of all, we need to declare an array of a particular type, in this case integer. And then we have an index value that will show us what array element that we are pointing at any given time. And in this case, it's going to be I. So I is going to be our index value. And I starts from 0. So it will go the size of the array, right? Size of the array minus 1. The size of the array minus 1 is ensured by the less than sign. So make sure that you don't use the less than or equal to. Okay? So it is just not a good programming practice to maybe use less than or equal to 99. Okay? It works perfectly fine. But when we're really looking at an array, as you program, you're going to be thinking about, I need 100 items, or I need 100 customers, I need 200 customers, or I need 200 cars, or 200 computers. That's how you think. So you're going to be thinking about that. So always use the actual size of the array, the actual number that you want to store, and then use the less than sign as a good programming practice. So that way we can, as we read the code, as we read somebody else's code, we can see it's still referring to what is the size that we are processing. It's just less confusing that way. Okay? But you can see it's just a counter control, because we know before we declare the array, we need to know its size. So we know exactly what the maximum size of the array is. So it is going to be controlled by the size of the array. So array operations are most of the time going to be for loops, because they are counter-controlled loops. So in this case, you can see that we're going to be reading in to an array one element at a time. So in each iteration, okay, so we have the array of all the elements within the array, and we are specifying each location by the index value 0, 1, 2, 3, 4, 5, and so on. Okay, so in the first iteration, we're referring to the 0th element. In that case, whatever we write in, you can see it's a cin operation, so it's coming from the terminal. So whatever the user types in is going to be stored in the 0th location, And when we increment the loop control variable, right, then we go through the comparison, and in this case we are at 1. So next time when we're asking the user to type something in, the user will be typing something under index 1. And the next loop starts. At that point, index is incremented to 2. So in the third loop, I value is 2. So whatever the user types in, we're going to be storing under 2. So a for loop is a very good way of controlling what is going to happen in each iteration, and an easy way to step through the whole array. Now I say it's easy to step through the whole array, but what if we referring to some values that are not within the array? In that case, the index is in a out of bound condition. So an inbound condition, and that's why it's going to be very important when you compile your code, when you write your code and you compile it, look at the error messages. As you're getting error messages or your application will crash, make sure you look at the error messages and read the error messages. And if you see anything referring to out of bounds, now out of bounds is going to be referring to somewhere in your code an array. So it's going to crash because C++ does not provide any kind of protection from out of bounds conditions. So out of bounds can easily happen. It is the job of the programmer to avoid out of bound conditions by coding it and validating the index values. Okay. So arrays can be initialized during declaration. The nice thing about that, there is no way you're ever going to have an out-of-bound condition, because you can see the values that are placed between the curly braces and size the limiters by the number of initial values in the actual braces. So we do not have to say how many elements we're going to have in the array, because the number of elements within the braces will identify the size of the array. So in this case, it's going to be assumed that there was a 5 when we declared the variable. So 5 elements specified by the number of items in this value list in the braces. But you do not have to specifically say. So this way you don't need to worry about referring to -1 position or index value 5 or index value 6. Right? You can see that it's going to be index value 0, 1, 2, 3, 4. So the number of elements is 5. The number of elements are 5, but the highest index value is 4. And you don't have to worry about those numbers or the indexes, because the list of items will tell you what's going to be, how the array will be initialized. Now, if you have a statement, this works with integers, okay? If you have 10 items in the list and you put a single 0, no commas, single 0 within the braces, then all 10 items will be initialized to 0. Now the items are evaluated from left to right. So the very first item on the left is the 0th element. So if you actually put in a value, remember when you declare an array, you can also give the number of items in that array. If you do not say the number of items in the declaration, which is right between the brackets, which is the subscript operators, right? Okay, so if you would avoid this 10 right here, and you would not use it, okay, this would be a perfectly good statement. But what's going to be the difference? The difference is the array called list will only have 3 items in it. Now, if you do put in the value, it is an array element of 10 items, where the first, second, and third item are going to be initialized, but all the rest of the components are going to be automatically initialized to 0. Okay, so there's a difference between if you're going to put a number in here or not. Okay, so think about that a little bit, and we can do some exercises on that as well later on. So aggregate operation, any operation that manipulates the entire array as a single unit, is not allowed on arrays in C++. So you don't just say one array copy to the other array. Okay, no, you try to assign one array to the next array. Okay. Now, even if it would be allowed, I mean, what does that really mean? Okay. So if you have 2 arrays, okay. Let me do 5 elements. Because that's what this one shows. So let's say if we have one element, or one array, okay, and then we have another array. Okay. So if I like to have 2 different arrays, 2 separate arrays, and let's call this X, and that's going to be Y. But what is really X? X is really a reference. A reference is basically a memory address. Let's say 0x5. So what happens when we are assigning Y to X? Y can be pointing to a different address, right? So when you're trying to say X is equals Y, Y is assigned the value of X. You're not assigning each individual values from Y, but you're trying to assign the reference pointer, which is 0x6 to X. So really what you're trying to do in this case is that X would be pointing to the exact same array, not its own copy of the array. Okay, so try to think about that, named identifiers are just reference points, and those reference points, you do not make a copy of them, you just assigning the references from one array to the next, and that's illegal. Okay, so the equal operator will not go through every single one of the elements in the array. It would only assign the array address, what we'll call base address, to a new identifier. So this is not allowed. So we cannot just use a simple assignment operator. So what you need to do is, each one of the items, if you want to assign y to x, okay, maybe 1, 2, 3, 4 items, what you need to do is take the index value of each item, and one at a time you assign each value, not the reference of those values, but each value you copy over to x. And that's what this for loop accomplishes, right? What you do is the same index value, right? So in the picture you can see that one's going to be copied to x, index value 0, because this is index 0, this is index 0. The same index value gets copied from y to x. This is your first element, the first index, index 1, so that x gets 2. And then we increment the index. Now we are pointing to index 2 in the y array. So that means the x array, index value 2, also receives the same value. So one at a time, you go through the array with a for loop and copy each value. Now, arrays are passed by reference only. So you do not have a choice. Okay? You do not have a choice to press it by value, and you can see that you will not have to specify that these identifiers are passed by reference, because you don't have any interruption. Okay? So you do not have to say it is passed by reference, because all arrays are going to be passed as reference, and there is no other way. Now when you are sending an array to a function, usually you omit the size of the array. Even if you would provide it, it would be ignored by the compiler. Now, why would you send an array as a constant? Now, that's going to be a very important concept. Right? So remember what happens when we send something to a function by reference. Okay. So let's say we have the main program, okay, and the main program has x, and let's say x is equals to 5. Okay. What happens if we're going to call a function? Okay, let's call f1 with x. What's going to happen? So what is f1? When f1 receives x, right, maybe receives it as, let's call it a, right? So what happens if we say a equals a plus 1, and it just returns. Okay. So what happens when we make this function call function 1? Okay, and we would call function 1 by reference. When we make changes to a, that's going to make change to x, right? So after the function call, x would be 6, because the function receives the memory address of x. So a is referring to the same memory address as x. So by being manipulated, when we manipulate the value from the function, it actually manipulates the memory address value, and main is pointing to the same memory address. So why is that a problem? See, if you if you're sending the array as a constant, right? So you're sending the array as a constant. When the function receives it and it tries to manipulate any one of its values in the function, you get an error message. So you can give somebody a list of items, and you can tell somebody, do not change anything on this list of items. Well, if you're just sending the reference, that person that you're giving this list of items, that person can say, yeah, sure, I'm not going to change anything. But there is no protection that the receiver will not change, and it will obey the rules. Now, just because you're saying the constant value, okay, any function that tries to manipulate the values, because it is sent by reference and we do not have any other choice, right? Any function could change the array values, but now you are ensuring that it is going to be basically read-only, and you cannot change it, even if you are sending it to another function. Okay, so think about that as read-only. Okay, so in this case, let's say y is going to be sent to the function as read-only, and then x is going to be read-write. So any function is going to be able to change the values in x, because we are not sending it as a constant. So base address of an array is a memory location, right? So an array name is also an identifier, and the identifier is just a named memory location. So the base address is the first component of the array. So if we have an array, and the array has a few elements, index value 0, 1, 2, 3, 4, and we call this A, array name is A. Array is pointing to the beginning of the first element, which can be referred to as A or A subscript 0. It's all the same thing. So when an array is passed as a parameter, the base address of the actual array is passed to the formal parameter. So not the value. Okay. Let's see. We're holding 5 in here, right? But this base address is, let's call it 0x4. Okay. So when we are sending the array to the function will not receive 5. Okay. It will not receive 5. What the function will receive is 0x4, which is the memory address where the array starts. And that's going to be the formal parameter within the receiving function. So C++ does not allow functions to return a value of type array. Okay? So you cannot return an array from a function. So when you have integral data types, we can use the enumeration type to improve code readability. Okay, so that's what we were talking about at the beginning, that we used enumeration type before we learned about arrays in order for us to understand how to make our code more readable for somebody that tries to interpret or fix or maintain our code. So we would say, we would put things in the array, and we would say 0, 1, 2, 3, 4, 5, and 6. It might not mean anything to the reader that reads our code. But if we say that green is 0, red is 1, blue is 2, brown is 3, white is 4, orange is 5, and yellow is 6, like in a enumeration type, then you can see that it's easier for us to refer that the paint sale red equals paint sale red plus 75.69. It's easier to see what is it that you're trying to do. Well, seems like we're holding the sales of maybe a lot of paint. Which one are we trying to increment? The red paint sales. So it's not going to be index value 1, whatever that is, and I need to increment it, but you can see that the identifier array has a meaningful name, and now the index value also have a meaningful name. So a human reading it, they can just say the red paint sale needs to be incremented by 75.69. It's easier to read. That's why you want to use strings, or not strings, but enumeration types that are still integral types, but humans will read it like it is a string. Okay. So when we are declaring arrays, okay, we talked about it has to be a constant value. So the constant value needs to be used in order to initialize an array. Because we're not going to cover what a dynamic array is. Okay, so you can dynamically create arrays, but it's not going to be in this chapter. So don't think that it's not possible. It is possible. But as far as we know in this class, we have to know the size of the array, and that the size of the array has to be a constant value. But here, even when we're using the constant values, it's always going to make more sense to use an identifier, a constant identifier, because again, you can see that this, if you name it number of students, and the array called test scores, human can read that it's this test scores for all of the students. Okay, so again, it's you would use these constants for readability of your code. Okay. Now, if it is too long to type, right? Then what you do is you can also use a type definition to make it much simpler. So every time you refer to a array, that array will always be initialized with 50 because of the constant value. So in this case, you can see that you can just have list your list and list my list. It looks really simple, like any simple data types. You can initialize, or you can declare variables of the simple data type. But the type def will ensure that the size always going to be a 50, and the array is going to be the data type double. But now it's much easier to refer to that. So then we need to look at different ways of searching through an array. So we need to look at the names and what is the algorithm. So basically, what is the pseudocode for an algorithm of a particular name. So in this case, we have sequential search or linear search. How does that work? Searching a list for a given item starting from the first array element. And then we compare each element in the array fit the value being searched for. Continue the search until item is found or no more data is left in the list. Okay. So basically, you can also look at this from a flowchart point of view. Right? So you say, I need an item, okay, and that's what I want to search for. What does that entail? Well, we need to process the array, each element, right? So how do we process an array? It's a for loop, right? So we go through every single element, and then what do we do with each one of the elements? Okay. Then we're going to compare it and see if the item what we're looking for is equals to the array at index, right? If it's false, if it's not, right, go to the next item, go to the next array element. Okay. So, but if it's true, we break the loop, right? We break out of the for loop, and then maybe we're gonna display the array at index, because that's going to be the item. That's going to be the item that we were looking for in the array itself. Right. Now, if we do not find it, right? So if it's not in the array, we go through the whole array, and after that, we're just going to say, well, it's not there. Okay. So you can look at this as a pseudocode. You can convert it into a flowchart. The main thing is, at this point, you have to have a basic idea. What do you mean by an algorithm? An algorithm, in this case, is a sequential search algorithm that will process an array for a particular item. Now we have sorting, right? So we talked about the whole concept of, later on, it's going to be very useful to talk about sorting. Okay. Now let's just have a basic idea that what happens if I have a classroom, and within the classroom, okay, we have chairs. Okay. Let's see. And then we have these chairs. Let's say we have a male sitting here, a female sitting here, another female, right? So everybody sits wherever they want. So we have male, and then female, and male, 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 maybe female, male, male, male. So how would you figure out how many males and how many females are in this class? Okay, you would probably start at a chair, right? And that chair, you might call it 0, 1, 2, 3. Okay, and this is in my first row, so maybe I want to represent the first number going to be row, and then each one of the values following it would be the columns, right? And then you would go to the first, and then 1, 0, 1, 1, 1, 2, 1, 3, right? And then you would jump to the next row. So, okay, this is my second row. Okay, and then 0th element, first element, second element, third element, and then jump to the next one. 3, 0th element, first, second, and third element, right? So you go through every single one of the chairs, and it's okay, asking the question, who is male, who is female, right? So that requires a two-dimensional array, and in each separate box. How do we stop in each one of the box? Through the use of nested arrays, nested loops, and then we have a selection statement figuring out if a male or a female sitting on that chair. And you have to go through the whole element, the whole class all the time. Okay. Now, what if we would change this? What if we would have a system where we would say that everybody in the classroom that's male has to sit on the left side of the room, and all the females have to sit on the right side of the room. Okay. So that means it is an ordered, a kind of a sorted list, right? Then we need to ask a question: how many males are in this classroom? We don't have to go through the whole array, right? Instead of processing the whole array, we only processing the array that holds male students. And then if we need to ask another question about the female students in the classroom, right, we would only process the section of the array that has to do with female students. Now, in order to do this, we need to sort it. We need to sort the array. And after we sort the array, because now it's a more ordered list, an ordered group, now we can have different algorithms going through, and now we can say, okay, how do we search this ordered list? So that's why the whole concept of sorting is going to be important. Now, one of the way to sort, okay, so there's many different ways to search a group, and there's many different ways of sorting a group, and one of those ways is a selection sort. Now, what is a selection sort? We are trying to rearrange the list by selecting an element and moving it into its proper position. So how does that work? That's why it's important to know pseudocode or maybe flowchart before you start figuring out how do I implement this algorithm. So now we need to find the smallest element in the unsorted portion of the list. Move it to the top of the unsorted portion by swapping the element currently there, and start again with the rest of the list. So how does that work? Okay. You can see that we have an element. Now, when we're talking about an element, right, we don't talk about swapping like you would swap on a piece of paper. Okay. So maybe there's an element, let's just call it X. And this is going to be my element, and let's call it Y. Okay. How do I make that swap? First of all, whatever is in X, what I might have to do is create a temporary holding place and assign whatever is in X. Okay. Then I can take whatever is in Y let's just save whatever is in y first, okay? Because we want to replace that with x. Okay, so let's save whatever is in y so we don't lose that data. Because if we just take 5 and we store it in y, what's going to happen to 16? It's going to be gone. So we don't want to lose that value. Okay, so what we're going to do is have a temporary place where we're going to save y, and then we're going to take y and store whatever is in x. And at that point, we can take x and assign whatever is in the temporary holding place. So that way you can see that first we need to store this, right? So now it doesn't matter if we overwrite it. Now we can overwrite it. But because we overwrote it, okay, we did not know what was there before. So then we take whatever is in the temp variable and assign it to this location. So the three-step process. And we're talking about humans talking about swapping. Okay, you kind of remember what 16 is. When you erase it, you write down 5, and 16 is still in your head, and then you overwrite, erase 5, and then overwrite it by whatever is in your head. Okay, so you do the same thing, but computers, we need to specify the order of operations in order for us to do it the right way. Okay, so C++ allows auto-declaration of variables. Data type does not need to be specified. So in this case, if you use the keyword auto num equals 15, num is assumed to be an integer. Now that is kind of, I mean, you're asking for trouble, right? Because if you just say num, and you would like num to be a double or floating point value, that's not going to work, right? So if you don't have to just because it's there, it's much better to know exactly the data type and use the particular data type that you want. Okay, so this auto declaration will not know exactly what you needed it for. So especially when you're talking about the difference between the float and the double. Okay, if you want a particular data type, it's better not to use auto. And as you can see, not all versions of C++ will actually support this kind of auto declaration of variables. Now, another interesting concept when it comes to for loops, we talked about that we have problems in for loops with keeping track of the indexes. Now, the indexes are very useful, but we need to know what is the range, the inbound range for the indexes. Otherwise, we're going to make a lot of mistakes. So again, C++ now allows you to use a shorter version of a for loop. Okay, so in this notation, remember we don't have the three different concepts. So basically, update is missing, right? So we need to look at that this is the variable that will hold each one of the elements from the array. So this is the array that we want to process. Now this array is going to store each one of the elements in num. Okay, so think about num, that we used to look at it as I, index value I, right? But now you do not have to specify the index value. But what you need to be careful is the type of the array. Okay, so if the type of the array is, let's say, an integer, then the variable that's going to hold the values, individual values, have to match the same type. And that's the only thing that you need to look at, okay? So you need to look at the type of the list. So in this case, somewhere in our code, we have a double list. Okay, and maybe we're gonna have a let's say 5-element list, right? So if you look at the type of the array, so there's going to be double, then we need to make sure that the variable that we're going to process each array element is also going to be a double. And then it works with this notation, and we only use a single colon and not the semicolons like we used in the regular for loop. So some people refer to this as an enhanced for loop. Okay. So that should be enough for one day. So next time when we meet, we're going to talk about this concept of C strings. So see you next time.